Welcome back. In this video, we are going to write equations for piecewise functions. So here I have two different pieces that I'm going to write equations for, and we'll write it in function notation. F of x equals this line over here. Let's start on the left side. It looks like it's going up 1, right 1, up 1, right 1. So it's got a slope of 1, so it's 1x or just x. And then it crosses the y-axis here at 0, so x plus 0, or just x, that's fine. F of x equals x is the equation of this line. And it's for x values that are to the left of x equals 0, so less than 0, and it looks like it actually touches 0, so let's call it less than or equal to 0. Then on the right side, the slope is up 2, right 1, up 2, right 1. So the slope is 2, so 2x, and it crosses the y-axis also at 0, so 2x plus 0, or just 2x. For what domain? The domain is all x's to the right of 0, so greater than 0. And it looks like it's touching 0, so let's say greater than or equal to 0. On to our next one, we'll start with this left side. So we've got f of x equals, so here we've got a slope of up 1, right 1, so a slope of 1, so that's just x. Okay, now I think we can use this graph to figure out where this is going to cross the x-axis, or the y-axis. So up 1 and right 1 would be here, up another 1 and right 1 would be here, right on the y-axis. So we're at 1, 2, 3, 4, 5, 6, 7, 8. So it's going to cross the y-axis. If it were to go that far, it would cross the y-axis at 8. Okay, now what's the domain? So it's for x's that are to the left of or less than x equals negative 2. So 2 to the left. And it's open here, so not equal to, so just less than negative 2. Then we have one that's horizontal, and it appears to be down about a half, so we're going to say f of x equals negative 1/2. No x here because it's a constant straight line, it's a constant function. Horizontal, no x, so y equals negative 1/2. Okay, so for what domain? That's for x's that are to the right of or greater than negative 2. And it's filled in, so greater than or equal to negative 2. Next, we're going to have three pieces here. So f of x equals, so first, we've got a slope of 1, up 1 and right 1. So a slope of 1, so 1x or just x. And it doesn't quite go to the y-axis, but if we went up 1 and right 1 again, here's where it would have crossed the x-axis. Up 1, so the y-intercept would be 1. Okay, for what domain? That's for x's that are to the left of or less than negative 1. And it's filled in, so less than or equal to negative 1. Then we have this piece here, which also has a slope of 1, so it's up 1, right 1, so y equals, or f of x equals x, and it crosses the y-axis at 2, so the y-intercept plus 2. And that one is for the domain of x's that are to the right of negative 1, but to the left of positive 1, so we'll write it like this. That is for x's that are greater than negative 1, but less than 1. And both of these are open, so that means not equal to. So greater than negative 1, but less than 1. Then our last part, once again, we have a slope of 1, up 1 and right 1, so x. And then if we extended it this way, it would hit the y-axis where y is 0, so just x, no y-intercept. The y-intercept is 0, so plus 0. So that is for what domain? That's for x's that are greater than x equals 1. And it's filled in, so it's really greater than or equal to 1. And our last one, we've got 3 pieces again, so that's f of x equals, so our line here, or our ray, goes up 3 and right 1, up 3 again and right 1, so 3x plus some y-intercept. So let's figure out that y-intercept. This time let's use point-slope form to figure that out. So we've got y minus y1, so we actually need a point. So let's use this point right here, -3, 1. So y1 would be 1 equals m, the slope, which is 3, times x minus x1, which is -3. So when I distribute, I get y minus 1 equals 3x, and then minus negative is really plus, so plus 9. And then we're going to add that 1 and get y equals 3x plus 10. So plus 10 for our y-intercept. Now, what is the domain? So that is for x's that are to the left of, or the less than side of, x equals -2. So we're 2 to the left here. So x is less than -2. That's closed here, so I could say less than or equal to. Then we have a constant function here, a horizontal line up, 1, 2, 3, 4. So f of x equals 4. For what domain? That's for x's that are greater than -2 and less than +2. So it goes from -2 to +2. And it's filled in on both sides, so we can underline those and say greater than or equal to -2, less than or equal to -2. Then we need this third piece here. So this one has a negative slope, and it's falling 1, 2, 3, and running 1. So -3 over 1, or -3, is the slope. Okay, then to get the y-intercept, let's use this point right here, 3, 1. So we've got y minus y1 equals m, which is -3, times x minus x1, which is 3. So that's y minus 1 equals -3x plus 9, and I add that 1, and I get y equals -3x plus 10. So plus 10 for our y-intercept. And for what domain? That is for x's that are to the right side, the greater than side of x equals 2. And since it's closed here, we'll say greater than or equal to.